Good day. We are the Team Ang and we are here to discuss our topic entitled Converting Work from Human Footstep into Sustainable Energy. Many people around the world have benefited from industrial progress, but it has also resulted in the depletion of natural resources and environmental devastation. The usage of fossil fuels, which has fueled much of industrial progress, has been identified as a major contributor to climate change. Climate change is projected to have significant economic consequences due to its effects on global ecology. As a result, new ways to fuel industrial expansion must be discovered to avoid jeopardizing the improvements of human well-being made in recent decades. People are increasingly turning into alternative energy sources to address the economic, environmental, social, and political issues associated with the usage of fossil fuels. Alternative energy sources are widely characterized as energy sources that do not produce or restrict net carbon dioxide emissions. Hence, avoiding the environmental consequences of fossil fuel combustion, solar, wind, bioenergy, hydropower, geothermal energy, wave and power, and waste to energy are all examples of novel and renewable energy sources. Deploying various renewable energy technologies is an important technique for achieving environmental sustainability. The vast majority of people walk for most of their lives. Walking is also known as the ambulation, and it is a basic and commode of human mobility in everyday life. A footstep power generator can be used to turn this energy into electricity. In this study, a mechanical footstep power generator is constructed based on the piezoelectric materials and DC generators. In order to reduce the complexity of mechanical structure, the components included in the proposed mechanical footstep power generator are the footstep arrangements, piezoelectric materials, DC generator, light bulb, inverters, and battery. The general objective of this study is to determine if the footstep power generator could be a potential alternative source of energy aside from the existing renewable and non-renewable energies. The specific objectives are to learn about the mechanism of electromagnetic generators that would play the biggest role in the whole energy production, to learn more about the piezoelectric that would be demonstrated by utilizing the footstep power generator, and lastly, to assess the quality of the materials that would be used in the generator.
This study's mechanical footstep power generator is based on the piezoelectric materials and DC generator to simplify the mechanical structure. The construction of a mechanical footstep power generator is shown in the figure below. So this figure shows the block diagram of the mechanical footstep power generator. Simply, individuals will walk across the footstep generator to test the effectiveness of the project. The project will activate when humans step on the piezoelectric materials. The whole mechanism will activate and generate the mechanical energy into electrical energy. When piezoelectric materials gets from the footstep, the electrons will flow to the DC generator and will store the electricity from the piezoelectric material to the battery. From the battery, the inverter will activate and light up the bulb. The single footstep of the individual can generate up to 5 watts, enough to light up the bulb for 20 seconds. The experiment setup of this is the test subjects in this study must be involved in a group of healthy volunteers and must be consist of individuals without any foot disorders. The participants can either be kids or adults with a body range between 15 kilograms up to 55 kilograms. To minimize variation, the average reading from each group was taken. The test subjects must step on the suggested mechanical footstep power generator with their hindfoot, because according to the previous studies, when an individual is walking on a level plane, the hindfoot produces the most pressure, accounting for almost 1/3 of total foot pressure. Furthermore, Previous studies found no significant differences when comparing plantar pressure distribution produced by both men's and women's feet on flat surfaces, showing that the gender component has insignificant effects. Based on this data, the study hypothesizes that each individual's power can be maximized by stepping on the proposed mechanical footstep power generator with their foot.
For the results and discussion, a beneficial use of wasted energy is achieved through this initiative. We have become more aware of and concerned about the utilization of foot power. Having a functional footstep converter into an electricity mechanism will alleviate our energy-related problems. Our generation is facing a drastic increase of human population. By that means, it resulted to massive consumption of energy. By stepping, we can store all of the energy produced when weight is applied to the footstep frame in a battery. Then, after converting DC to AC, a storage system with an inverter circuit is built up to use the alternative energy generated in everyday applications. Thus, having the footstep generator would be beneficial as it involves everyday activity of a man.
So let's now discuss the battery backup time. What is a battery backup time? Battery backup time is the capacity of the battery to last. So battery backup time is equal to battery rating over load applied, which is our consumption to the battery. So theoretical power output. To determine the output power, it is essential to determine the force applied on the model. Let the force applied be calculated as force is equal to weight of the body times the gravity, and work done is equal to force times displacement, and power is equal to work done over second or time. So let the weight be applied by the body is 20 kg. Then the maximum displacement of the piezoelectric material is 0.05 meters. So in calculation, force is equal to 20 times 9.81 is equal to 196.2 Newton. And work done is equal to 196.2 times 0.05, which is equal to 9.81. And the power is equal to 0.981 over 60, because 60 minutes for an hour is equal to 0.1645. So the power generated per hour is equal to 0.1635 times 3600 is equal to 588.6 watts. This result is what we assume in theory that we will get in 1 hour. So in practical power output, power can be calculated in terms of obtained voltage and current when load is applied on the footstep frame. The ratings are noted by using the multimeter, so we can measure the voltage using multimeter. So force is equal to voltage times the current. So for one step of 20 kg of load applied on the footstep frame, the generated voltage is 2.6 voltage, and the average current produced is 12 milliampere. So in calculation, power is equal to 2.6 times 0.012 is equal to 0.0312. So in conclusion, power generated per hour is equal to 0.03112 is equal times the 3600 is equal to 112.3 watts. So thus, the obtained power for continuous load applied of footstep for 1 hour is 112.3 watts. So this result is what we obtained from the experiment, or the assumed experiment of our project.
The mechanical footstep power generator is the subject of this project. When a human steps on the piezoelectric materials, the entire mechanism activates and converts mechanical energy into electrical energy. When piezoelectric materials come in contact with the footstep, electron flows to the DC generator, which stores the electricity from the piezoelectric material in the battery. The inverter will activate and light the LED powered by the battery. An individual single step can generate up to 5 watts, which is enough to light the bulb for 20 seconds. The goal of this project is to convert wasted energy into useful energy. The concept of using food power has become relevant and important. Incorporating this functional footstep converter into an electrical mechanism would solve our energy problems. Thus, they come up with the idea of converting footstep into electrical energy. This project is environmentally friendly because it does not emit carbon dioxide, which pollutes our atmosphere. It only converts mechanical energy from the human body into alternative energy that we can use for everyday life, or to light the streets. In the near future, this could be one of the sustainable energies that can benefit humanity. If there were a footstep generator on every sidewalk that was connected to a battery and stored on it, it could be used for our appliances or device that needs a battery to function. Converting energy means this can be potentially alternative, sustainable energy source for the future. The footstep power generator could convert kinetic energy into electrical energy and would be beneficial to the human race. The utilization of the footstep power generator could convert to the wasted energy in locomotion and power up electrical energy in institution and establishment.